This screencast will review naming and formula writing of chemical compounds. The prefix bi means two, and binary compounds contain two different elements. Ionic compounds are a metal bonded to a nonmetal, and covalent compounds consist of two or more nonmetals. To name the traditional ionic compound, you use the element name for the first element, the cation, and then you change the name of the anion by changing the ending to "ide." For example, KCl contains the potassium cation, so we just name that potassium, and then we change the chlorine to chloride, so this is potassium chloride. MgBr2 would be correctly named magnesium bromide, and calcium and oxygen would be calcium oxide. The second type of ionic compounds contain transition metals, which can form more than one type of positive ion. So we need to specify the charge on the metal by using a Roman numeral in the name. For example, copper bromide contains copper, which can have more than one charge. Since the bromine always has a -1 charge and is bonded to the copper in a 1-to-1 ratio, the copper must also have a 1 charge. So this would be correctly named copper 1 bromide. Manganese is a transition metal that can have multiple charges, but oxygen always has a -2 charge. Since there are two oxygens, the total negative charge is 4, and the manganese must have a +4 charge to form a neutral compound. So this would be correctly named manganese 4 oxide. Finally, iron bonds to sulfur in a 1-to-1 ratio. Sulfur always has a -2 charge, so the iron must have a +2 charge. This would correctly be named iron 2 sulfide. There are some exceptions to the transition metal rule. Silver, zinc, and cadmium, although transition metals, always have the same charge. Therefore, when you are naming, you don't include Roman numerals with either of these elements. On the other hand, lead and tin are not transition metals, but both of these elements can exist as a +2 or a +4 ion. Therefore, you do need to include Roman numerals when naming with these elements. We can also have compounds which contain polyatomic ions, so you will want to review common polyatomic ion names and their charges. For example, sodium is bonded to the group of atoms phosphorus and 4 oxygens. They carry a -3 charge, and so there are 3 sodiums to balance this compound, and we would call it sodium phosphate. In this second example, magnesium is bonded to the polyatomic ion called nitrite, so this would be magnesium nitrate. And finally, we have copper bonded to sulfate. Copper, as we saw in a previous example, can have more than one charge. The sulfate ion always carries a -2 charge. Since there are 2 coppers to balance the sulfate, the copper must have a +1 charge, and this would be correctly named copper 1 sulfate. The final type of compounds that we name are covalent, and much like ionic compounds, the first element uses its traditional name, and the second element name, the ending is changed to IDE. The difference is we use prefixes to communicate how many of each type of element are present in the compound. The only exception to this rule is that we do not use mono when there is one of the first element. You should review the prefixes for indicating the number of atoms going from 1 to 10. Let's look at some examples of this type of naming. The first example, CO2, I'm sure you learned a long time ago, is called carbon dioxide. But now with our naming rules, we can see why. There's 1 carbon, so we do not use a prefix of mono since it's the first element, and the prefix for 2 is di. A second example, SF6, again there's 1 sulfur, and then the prefix for 6 is hexa, so this would be called sulfur hexafluoride. Finally, this compound has 2 nitrogen, and then the prefix for 4 is tetra, so the correct name for this compound is dinitrogen tetroxide. When you use the prefixes with oxygen, you typically drop the vowel on the prefix and keep the O from oxygen. So instead of tetraoxide, it's tetroxide. This flow chart can be used to refer to when following the naming process. If it's a binary compound, the first question you ask is, does it contain a metal? If the answer is no, that means it's a covalent compound of two or more nonmetals, and you use prefixes to name the compound. If it does contain a metal, then you must ask a follow-up question in that, does the metal form more than one positive ion? If the answer is no, then you name the first element with its traditional name and change the second element ending to IDE. If the compound does contain a transition metal or a metal with more than one charge, you must determine the charge of the positive ion and then use a Roman numeral in the correct name. To summarize, here's one final example of naming, and we need to determine which of the following compounds has the incorrect name. If you look at letter A, potassium is a metal and it only has one charge. It is bonded to the polyatomic ion nitrate, so this is correctly named potassium nitrate. We're going to skip over letter B. Tin hydroxide here. Hydroxide is a polyatomic ion that carries a -1 charge. Since there are 4 of them, then the tin must have a +4 charge to form a neutral compound. So this is correctly named tin 4 hydroxide. Letter D. Phosphorus and bromine are both nonmetals, so this is a covalent compound. There's just one phosphorus, and the prefix for 5 is penta, so this is correctly named phosphorus pentabromide. Calcium is a metal that always has a +2 charge, so we don't need a Roman numeral, and it is bonded to chromate, so this is calcium chromate. So the one that I've skipped over, letter B, is the one that's incorrectly named, but let's see why. Again, oxygen always has a -2 charge, and since there are 2 of them, the total negative charge in the compound is 4, which means the titanium must have a +4 charge to balance the compound. So the correct name should be titanium 4 oxide.